And we're back. We got about 2 weeks left of new material. This is actually going to be our last week of new notes. Next week, I think I'm just going to do a sequences and series recap on Delta Math. There's some decent stuff on there with this, so I think we'll just do that. So, last week of new notes, new material. We'll have a worksheet, 10 questions over arithmetic and geometric series. So a series in general is just the result, the sum of adding a bunch of terms or a certain number of terms in a sequence. So whether it's arithmetic or geometric sequences, doesn't matter, but a series is just the sum of all of those. So some notation that you're going to be seeing, some formulas you're going to be seeing here, you have here, sum or S sub n equals n times a sub 1 plus a sub n all over 2. So all that means is you have to figure out what the first and the nth term is, whatever you're looking for. It could be the 20th term, it could be the 100th term, whatever it is. You add the first and you add the last term that you're going to look in between. Divide those by 2, and you're going to multiply by the number of terms that you have in the sequence. And that's going to give you your result if you just added a set of numbers. So like if you wanted to add 1 plus, or 1 through 10, 1 plus 2 plus 3 plus 4 plus 5 all the way to 10, you would just add 1 and 10, get 11, divide that by 2, you get 5.5, and multiply by 10 terms in that sequence, and it's 55. So 1 plus 2 plus all the way up to 10 is just 55. Alright, but this is meant for obviously bigger sequences than just doing a smaller set like that. Another notation you're going to see is this. What that means, all that's saying in words, is find the sum of the arithmetic sequence 2n plus 3 for values of n from 1 to 20. So this bottom number is where the first term starts. I'm just going to give it to you as the first term of the sequence. Top number is the last term in the sequence that we're looking. So between 1 and 20, this is your arithmetic sequence, and we got to find the sum of those first 20 terms. So let's look at that exact same notation. Let's look at the actual work to this. So I put up in the top corner here your formula you're going to need. So we have this. First step, I don't need to see work for this. You can just do this in your head. Find the value of your first term. So you just plug in 1, you get 5. 5 is the term you're worried about. You do the same thing. You got to find the 20th term. Plug in 20, see what you get. You get 43. So 5 and 43 is what I'm worried about here. Then you just plug it into the formula. There are 3 things you're plugging in. An n, an a sub 1, and an a sub n. N is just the number of terms, so 20 terms. 5 for a sub 1, 43 for a sub 20. This is what it looks like plugged in. And this is the work that you may need to show from there. 5 plus 43 is 48. 48 divided by 2 is 24. 24 times 20 is 480. And that's all we're doing from here. Alright? Let's get one more, very similar to this. Different sequence. We got a negative common difference here. So let's just go through that. So again, in words, what this is saying is find the sum of the first 33 terms of the sequence, 7 minus 3n. First step, find the value of the first term. Plug in 1. See what you get. I get 4. Find the value of, it should be a sub 33. Didn't change that from the last problem. I plug in 33, see what I get. I get negative 92. Alright. Then you just plug it into the formula. This is what it looks like plugged in. 33 terms. First term is 4, last term is negative 92. Get negative 88, divide that by 2, negative 44, multiply it by 33, we get negative 1,452. Alright, so we're going to get some big numbers in these, so don't be afraid if you get some big numbers. I'll probably give you the start of some answers, but not the full answer on this. Now, last one we're going to look at with arithmetic, and then we'll run through these pretty quick with geometric. Geometric's a little bit easier with pulling out the information It's just a little bit harder to plug in, but we'll talk about that in here in a second. So I'm giving you something a little different. We're going to find the sum of the first 16 terms of the sequence. 20, 27, 34, 41. Notice, I don't give you the formula for it, so we need to find that. Alright, this one we don't know the explicit formula of the sequence, like I said. This is what the notation would be. We're finding first 16 terms of the sequence that we don't know. First step is to find the explicit formula of the sequence. So remember, we plug this in. This is a reminder from last week. A sub 1, your first term is 20. It's just our first term right up here. Our common difference is positive 7. You're adding 7 to each term to get the next. So we plug it in. We get a sub n equals 7n plus 13. Now we use that to help ourselves out. I don't need to see this. It's not something I'm looking for. It's just helpful. First term we know. It's 20. I needed the explicit formula to help me find the 16th term of the sequence. You can just keep adding if you want. I think it's less work to go ahead and find the formula first, then plug in 16. But we get 125 there. And then all we do is just repeat the steps that we just did in the last two problems. Plug it in, see what we get. You're always going to get a nice whole number with this when you add any type of number. So don't worry about that. So we get 1160 here. Geometric series, definition's the same. It's just adding. This one, here's our formula for it. To find the sum, all you need is the first term and the common ratio and the number of terms. Alright? I don't need the formula or anything like that. Alright, we need to know the first term, how many terms, and the common ratio. Notice we're going to get very large numbers on this one because we are dealing with some exponential stuff a little bit. Recall from our formula before, this is going to be coming up, but we're not going to need to find the formula. We just need to know a sub 1 is the first term, r is the common ratio. Keep this in mind. Alright, first one. We're finding the sum of the first 10 terms of the sequence 4 to the n minus 1. That still means the same thing. We're going to find the value of a sub 1. There's no work that needs to be involved. Alright, now just keep in mind here, I have a little side note here. This is technically 1 times 4 to the exponent. So your first term is technically 1. My common ratio is 4. Whatever's the base of the exponent is your common ratio. So my common ratio is 4, and then all I do is just plug that information in to a different formula. Notice again, exponentially we're getting bigger, so we're dealing with some big numbers. So I'm going to show all the work here. These ones we're definitely going to have bigger answers. Now again, I don't need to necessarily see the work, I'm just showing all the steps off to the side. I definitely don't need that 1 out front in this one because it doesn't do anything. But I get 349,525 if I were to add the first 10 terms in that sequence. Got that. Next one, exact same deal. 7 terms in the sequence. We have our first value, our common ratio is just 5, then 2. Then we just plug everything in. It's going to get bigger exponentially. So we have this. 5 times 127, we get 635. Alright, so we got that. Last one here, it's going to be similar to what we had in the last problem. Alright, we're going to find the sum of the first 8 terms of the sequence. I just have the sequence. I don't have the explicit formula again, but guess what? I don't need the explicit formula this time. All I need is the first term, which we know, 2, the common ratio, which we can figure out, negative 10 divided by 2, 50 divided by negative 10 is negative 5, and the number of terms is 8. Alright, so I don't need the explicit formula in this one. Find the first value, 2, which we already said. Find the common ratio. Little reminder here on how to find the common ratio when it's not given to you. And then you just plug it in. Now, careful here when you're plugging in a negative. Alright? bottom or top, negative 5 to the positive, or yeah, to the 8th power comes out positive. So it's 1 minus 390,000-ish still. But notice here it's minus and negative, so it turns to positive. So it's a positive 6. So just be careful here, please. You're dividing, you get a negative number, multiply by 2, still get a negative answer, and that's okay. Negative answers are just fine. But that's it. Hopefully this helps out. We have 10 questions, 5 on each series, and that's it. Hope you guys have a good week, and if you guys have any questions, let me know.